Integration is linear function. I can swap the sum and the integral. This will be the sum n equals 0 to infinity of the integral of x to the n dx. But that, I just increase the power by 1 divided by the new power. X to the n plus 1 over n plus 1. Okay. Plus c, I forgot my c. Okay. So that negative natural log of 1 minus absolute value of 1 minus x. Let me get rid of this. I'll lump the two c's together on the one side, is equal to the sum n equals 0 to infinity of x to the n plus 1 over n plus 1 plus c. Okay. Now this we could re-index to because I'd like my powers on x to be my indexing thing. So notice that this, when n is 0, I get x over 1. When n is 1, I get x squared over 2. Then I get x cubed over 3, x to the 4th over 4, etc. Then plus my c. Right? So I could really write this as the sum n equal 1 to infinity of x to the n over n. If I multiply through by the negative, I get natural log of absolute value of 1 minus x is negative this sum minus c, if you will. Okay. I'd like to figure out what my constant is. That's really my first term in the sum. So what I could do is, well, what's a value that I can easily evaluate this series at? It's center. If I plug x equals 0 in, that wipes out everything except for c. And plugging in 0 in here, I get natural log of 1. Right? So plug in 0. We get natural log of 1 is equal to negative c, but the natural log of 1 is 0, so my c is 0. Okay. So log of 1, absolute value of 1 minus x is negative of the sum x to the n over n. Log absolute value of 1 minus x is negative the sum n equal 1 to infinity x to the n over n. Okay. Wasn't this a series that we looked at last time? Maybe we had x minus 2 to the n or something. Okay. This has the same radius of convergence, so the centered at 0, radius of convergence r equal 1. Interval of convergence minus 1 to 1. If I check negative 1 to the n over n, well, that's an alternating series. Okay. That's the alternating harmonic series. Okay. So at x equal negative 1, we get negative sum n equal 1 to infinity, negative 1 to the n over n, which is the convergent alternating harmonic series. At x equal 1, though, we just get 1 over n, negative sum 1 over n, which is divergent harmonic series. So here my interval of convergence is including negative 1 to 1, excluding 1. Okay. So notice if I needed to know what's the natural log of 2 when x is negative 1, natural log of 2 would be negative, negative of the alternating harmonic series. Okay. So this tells me what the alternating harmonic series converges to. Okay. So the sum n equal 1 to infinity, negative 1 to the n over n, is negative log absolute value of 1 minus x or 1 minus -1, which is negative natural log of 2. Or move the negative in as a power, that's the log of 1/2. Now, I think we dropped the first term off of the alternating harmonic series. We had the sum 0 to infinity. Well, the first term is 1, so peel that one off, subtract 1 from that. Now you know what the alternating harmonic series converges to. Okay, until now, we didn't know that. All right, so that's differentiating and integrating, how to create new series from old by substituting or differentiating and integrating. Next, we'll look at what if I have a function. Can I find a power series for the function? Okay. Those are called Taylor and Maclaurin series. We'll look at those next.